just took a look at the lens equation, and we said we have this 1 over dO plus 1 over di equals 1 over f. We looked at the different sign conventions for f, what the sign conventions mean for di, and we said dO is always a positive value. So this one can be plus or minus, this one is plus or minus, this one depends. On object position. This one depends on the lens or mirror. But dO, we said, was positive, and that's almost always true. There is one exception, because it does come up as a question from time to time. Not a question that a book asks you to answer or anything like that, just, is dO always going to be positive? Just about. If I have a dO if I have a lens that looks like this, and then another lens that looks like this, and I put them near each other. So if I'm talking about multiple lenses only, I might have my object out here, and when I trace things out, I might get an image. So I'm going to ignore my second lens for a moment, and I might get an image here. That's the image formed by my first lens. So I'm saying, right, I did my thing. I said, here's this. Here's that. My ray 2 goes, I don't know, something like this. And this. And I've made my first image out here. Now, when I go to see what happens with my second lens, because I'm viewing this thing through two lenses stacked near each other, when I do this for my second lens, now my object is on the wrong side. Right, my focal point's out here somewhere, but I'm working with a virtual object now. Because I'm working with a virtual object, so this becomes image 1, and image 1 becomes the object for my second lens. This is lens 1, this is lens 2. Now, when it becomes the object for my second lens, d object 2, because I would do the lens equation twice, d object 2 is now a negative number because it's on the wrong side. That's all. That's the only time that becomes an exception. If you do not see two lenses, or two mirrors, or I guess a lens and a mirror type of situation, if you don't see multiple optical instruments in a row, then there's no way that you end up with a negative dO. The only way you come up with a negative dO is if the image formed by your first optical instrument becomes the object for your second. That's it. And that's not a question that you are likely to ever encounter, but it's easy enough to be able to look at the fringe case and say, here's what that is.